Welcome to Advanced Data Analysis 1 with me, Erik Erhardt, Professor of Statistics at the University of New Mexico. In this video, I'll get you started with plotting bivariate relationships when you have a categorical response. So go down to the timetable, and we'll scroll down to Class 8 for categorical response. We don't have a separate R Markdown file here, so the assignment must be in the outline file. So we'll take a look over at RStudio, and we have the file opened already, and I've already come down to class 08 plotting bivariate categorical response. Before I get started, I'm going to save this file as and the current date. And if I had any plots over here or any variables in my environment, I would click the broom to remove those plots and variables in the environment. That way I'm starting with sort of a clean slate. Another thing you can do is down in the console, it looks like I've got some stuff down here. If you press Control L, let's see if there's it might be under View. There is an option to clear the console. There it is, clear console. And that will just erase all the output that was previously in the console. Another thing you can do, if like for restarting the session, is, where is it? Restart R, Control Shift F10. That's the keystroke I know. So if I run that, that will, it depends on your settings, I think, but my settings are that I don't keep my environment, so it wipes everything out, and basically I know that I'm starting brand new. Okay, with that long introduction, let's get to the assignment. We have two goals. We are going to create two plots. One of them, using American English, not British English, we're going to create a mosaic or bivariate bar plot. So this is when you've got two categorical variables. X and Y are both categorical. And we're going to label the axes, give it a title, and provide an interpretation. Now I have a lot of plots for this section, but I am not going to cover all of them in this video. I may cover it in more detail when we do the statistical analysis of categorical tables, because at that point there is another type of plot called a mosaic plot where we get additional information that we can use for statistical inference, and we can interpret some of the colors in the plot. The second plot is a logistic scatter plot. Logistic regression is a type of regression where we have X as a numeric variable, but Y is a binary categorical variable. At least that's the type of logistic regression we'll be looking at the end of this semester and also in next semester. Again, we will label the axes, give it a title, and interpret the relationships that we see. All right, there are two sections down here. Let me just remove this for a moment. This is what you're going to see below the rubric. We've got a place for the mosaic plot and a place for the logistic regression plot. Okay. So first thing I'm going to do is paste some code in here. And this piece of code will give us a couple frequency tables with proportions. And the reason I'm starting here is because it's these proportions that we are interested in plotting. Okay. So let's so we've just opened our file. Let's set the working directory in session working directory to source file location. That'll open up the console and set that working directory. And then we're going to run all the code chunks above the one that we're working at. Okay, so that will load the data and go through all the rest of the analyses down here in the console. And because I clicked, it sort of stopped the output. Okay, there we go. Making some plots. And then we'll walk through what this code does right here. Some of these plots take a long time. I may eventually disable some of these plots so that during the video demos they're not taking such a long time. All right, so with all that run, I'm going to press Control L again, and that's going to clear the console. So now any output that goes in here will be stuff that we've run. All right, so I'm going to run this first table, and then we'll walk through what it does. But we're going to look at the output first. Okay, the output is a table where we have a column for depression and a column for nicotine dependence. These are two categorical variables. In my case, they're both binary. They both have two levels, but you could have one or both that have more than two levels. That's just fine. In my case, depression is either no or yes for depression, and my nicotine dependence is either nicotine dependent or no nicotine dependent. And I realized that if I was more consistent, I probably would have said yes, nicotine dependent, to be consistent with the depression. The column under N is the number or the frequency, and so there's about 31 or about 3,200 that where they're not depressed, but they are nicotine dependent, whereas there's 32,000 who are neither dependent or depressed nor nicotine dependent. Okay, and then these proportions, you can see that the first two rows, the proportions sum to 1, and the second two rows, those proportions sum to 1. So these proportions are conditional, and they're conditional on the first variable, depression. So out of the 100% of people who are not depressed, about 9%, 0.09, are nicotine dependent. Okay? Whereas, let's see, how should we do this? No nicotine dependent. Yeah, okay. So among those who are not depressed, 9% are nicotine dependent. Among those who are depressed, so yes, 22% are nicotine dependent. So it looks like there's probably a relationship here, that if you are depressed, you are more likely to be nicotine dependent, 22%, than if you are not depressed, where only 9% are nicotine dependent. And that would be a nice interpretation of this table. Now, the relationship might go the other way, and so that's what the second table is. I happen to do it in the other direction. I'll show you the output, and then I'll talk you through the code that creates the table. So I highlighted that code and pressed Control Enter. That submitted the code down to the console and then gave us the table. So now you can see nicotine dependence is the first variable. That's the one that the proportions are summed over. So among people who are nicotine dependent, let's do it this way. Among people who are nicotine dependent, 35% are depressed or have depression. Among those who are not nicotine dependent, only 16% have depression. So it's almost like if you have nicotine dependence, you're twice as likely, from 16% up to 36 or so, you're more than twice as likely to also be depressed. Okay. So those are some of the proportions we will be plotting in a moment. Let's just stay with the second example since it's here on the screen. We are going to assign the output of this to an object which I call tab, for short for table, nicotine, and depression. I start with the NESARC dataset, and then all the key to this is grouping the dataset by certain variables. So first I'm grouping all the rows of the dataset by the levels of nicotine dependence. Okay, and alphabetically those are nicotine dependence and no nicotine dependence. Alternatively, these are probably actually in the order that we defined the factor levels. Okay, So first we group the data by nicotine dependence, and then for each level of nicotine dependence, we then group the data further by depression. And so all the rows of the data set are effectively grouped as we see in the 4 lines of the table below. Okay? Now for each combination of nicotine dependence and depression, we're going to summarize what we see. And this creates the column n, and that column n is going to equal, there's a function n, and if you call that function, it counts how many rows are in the combination of categories for nicotine dependence and depression. Okay, so we've grouped by these two. When we summarize it, it goes through every combination. So it goes through nicotine dependence and no depression, and then it counts up how many, and that was about 3,200. And then for when there's nicotine dependence and yes depression, it counted it up, and we had 1,700. And then those were all the levels of depression within the first level of nicotine dependence. Then we go to the second level of nicotine dependence for no nicotine dependence. Then it goes through the levels of depression again. No depression, 32,000. Yes depression, 6,000. And that's what summarize does. Then, the last thing that summarize does is it drops the grouping of the last variable. So there's a little bit of magic in here. When you summarize, you sort of have to reduce the grouping because you've summarized over that group. So by the time we get down to mutate, the data is still grouped, but it's no longer grouped by depression anymore. It's only grouped by nicotine dependence. And so at this point, we're going to create a new column called proportion, prop, and that's going to equal n, which is the value in the n column, divided by the sum of n. And because it's no longer grouped by depression, but grouped only by nicotine dependence, that means that we're going to calculate the sum over the level of nicotine dependence. So we're on nicotine dependence. We're going to add these numbers up. It's something close to 4,900. And so you've got the value, say 3,200 divided by the total, 4,900. That's the sum. And we're going to round that value to 3 decimal places. And those are the values that go into the proportion. So that's how we get 0.643 and 0.357. And we do that for each of the group by variables. So then we move on to the second value of nicotine dependence. And for these 2 rows, we summarize, we calculate the sums. I guess we already did that. And then we do the mutate to get these proportions. And finally, just to make this output table a bit simpler, we're going to ungroup the grouping that we created so that there's no strange artifacts. If we go on to use this table for other things, we don't want this grouping to surprise us. So we ungroup it at the end, and there's no grouping anymore. And then this line just prints it out to the console. Okay, that was a lot of description, but these are new functions, and this is how we teach and how you learn. So my recommendation, copy this code, put your data set in here, probably name the same thing, put at least 2 of your variables in here separated by commas, and then the rest of the code can stay just as it is. You can choose to rename the table object if you wish, and make sure you rename it twice, and then print it out. And then look at the results and see if you can interpret what the results are. Okay, that is a table. Let's create a plot for one of these 2. So now I'm going to go to the website, scroll up to the model assignment. You can either use just the code that I'm producing in this video here, or you can go to the previous year's HTML. I believe that's here. And I've already gone down to the bivariate plots. In fact, let me not cheat so much. Here's what happens when you, let's just close this. Oh, are you going to be super slow? You are. Okay. Open up that HTML file, let it load, and I'll scroll down to graphing. The Thursday assignment, I guess, under week 4, bivariate graphs, mosaic, and logistic. All right, I have a bunch of stuff in here. There's other ways of creating tables. I use this all the time, cross tabs. It summarizes and gives you the frequencies. I usually like to see the proportions though, and this does not give it to you. So that's why I'm showing you the other tidyverse version here. But the way this works is for cross tabs, you specify your data set. And then after your tilde, in this first argument, you put the row variable. And then you add the column variable. And it will create a 2 by 2 table, or, depending on how many levels there are, a two-way table that gives you the frequencies. And so I assign that to T1, and you can even use that to create a very basic bar plot. Okay, but I'm going to skip over all these very basic plots and go to the ggplot plots. Let's look at a few of the plots, and then we'll come back and discuss the code. Okay, so here is a first plot where for each level of depression, no on the left and yes on the right, I've got a proportion on the y-axis of nicotine dependence, where the red is nicotine dependent, yes, and blue is not nicotine dependent. Now, these proportion plots start from 0 and go up. And we have this stacked, this is called a stacked bar plot. There's bars, but they're stacked because they sum up to 100%. Typically, our outcome of interest is going to be in the positive. So not that they're not nicotine dependent, but that they are nicotine dependent. And so in the next plot, I actually reverse it using a function up here, which we'll return to in a moment, which puts nicotine dependence as the blue on the bottom. And now we can see, okay, for the depression status no group, the proportion that are blue, nicotine dependent, are maybe about 45%, whereas for the yes depression group, it is about just over 70%. Now we can confirm those numbers because we created them over here. We are looking at, let me go back and forth a little bit, for a given depression status, we're asking about the proportion who are nicotine dependent. So let me scroll up to that output. Let's see, for some reason these do not look right. For a given depression status, what proportion are nicotine dependent? Oh, you know what? In the previous year, I restricted the data to only young adults up from 18 to 25 years old. This year, I am not doing that restriction. So these proportions do not equal each other, and that's okay. Okay, so let's not bother making that comparison at the moment. But this looks like a nice plot. We see that there's a difference in nicotine dependence depending on your depression status, and we could plot it the other way if we wanted to. Put nicotine dependence on the x-axis with depression status over here. All right, let's scroll down a little bit. I think I've got here is the same information, but I've faceted it by sex. So we have females on the top and males on the bottom, and looks like there's some differences here between females with more no nicotine dependence than males. So probably want to reverse the scales on this too and put nicotine dependence at the bottom to make that easier to interpret. Here's a case where we've got more category levels. So here's smoking frequency, where the most frequent people are on the right and least frequent is on the left. And nicotine dependence is the red bar coming down from the bottom. So the people who smoke every day have a larger red bar, so are more likely to be nicotine dependent than the people who just smoke infrequently. That follows our intuition. That's good. Okay, and differences by male and female if we want them by faceting. All right. So then there's a whole section in this code about using mosaic plots. I'm going to totally skip that in this video, but they are going to be valuable to us much later. All right, so let's go up and look at the code for how to make these types of plots now that we have an idea of what we're looking at, or why we're creating them, and what sorts of features we might be interested in. And I think I'm going to start with the second one because that put nicotine dependence on the bottom where I want it. You know what? Double thinking this. Let's start with the first plot because then I can show you how that reversing factor works. Okay, so here I've got, I've just copied the code. I'm going to make the same plot. I'm going to copy paste and run it without thinking too hard about it. And then we will look at the code more carefully and think hard. Control-Alt-I will insert a new code chunk, just as this will. And I'm going to paste that code in. This is where I would probably start if I was you. And the only difference is here is I would put in your data set, choose one of your categorical variables as the x-axis. Now fill means the fill color. Okay, so that's defining the red and the blue. So the fill color is the second categorical variable, tobacco dependence. And actually, you'll recall, I changed this variable name to nicotine dependence recently. That defines the axes, the x and the y axis, the x-axis and the color axis, really. Color is an axis, right? So you've got, say, x-axis in space, y-axis in space. Color is an axis just as well. And there can be other axes such as size or transparency can be an axis, lots of things. Anything, yeah, anyway. So the next thing is I'm going to plot bars and position fill. We're going to keep for now, but I'm going to show you some of the options there, but I think this is the right one for us. Theme, black and white. Let's just comment the stuff that we don't need for now. You know what? And we'll use a command for that. So I'm going to highlight all this stuff that is extra at the moment. Code, comment lines, and that put pound signs in the front of all these lines of code. Now we've got a really simple plot. Let's run it and take a look. We'll make the plot area a little larger. And this is already looking like a pretty good plot. We've got depression, no and yes. We've got nicotine dependence, sort of yes and no. So here we have nicotine dependence as a yes variable. Up on top, we want to swap the order here. We've got the y-axis says count, but it goes from 0 to 1. So these are really proportions. So we probably want to relabel that axis. Otherwise, we're pretty close to having a decent plot. One more thing I want to do is we've got within depression, I want to compare what we're seeing to the table that we made. So within the no depression group, we want to see the proportion that are nicotine dependent at the top. And that is within the no depression group, what proportion are nicotine dependent. And that's about 9% up top. That seems about right. On the right, we have in the yes depression group, what proportion are nicotine dependent. And that's, that is this third line. 22%. That seems about right. If it were to come down to the 75% line, that would be 25% from the top. So we are correctly plotting this table in this plot. I'm happy about that. Great, let's see a couple options now. Let's add the theme BW. And the main thing you'll see is that the background, the gray with the white grid lines, changes into a white background with light gray grid lines. Not important at all. This is the theme I tend to use. I encourage you to spend a little time, not a lot of time, looking at some of the themes to see what you like. Let's do a couple more things. Let's look at this geom bar if we don't do position fill. So what I've done is I've closed the braces, closed the parentheses, and I've put a comment so that this option is still hanging out in the code, but it's not going to be interpreted. Okay, so now the count axis is actually just counts. It goes from 0 up to the frequencies that we see. And if I scroll up to this table, right about there, you can see that the upper bound is about 32,000, which is the top of the blue bar. And if you add 3,200 more to that, you get the red bar. Okay? So I think for us, we're more interested in the proportions rather than the counts. So I'm going to put the position fill back in as the argument and look again at this plot. All right, so now let's do some labeling. I'm going to bring these lines of code back to life. Just there for now. Okay. And run it. So what have we done? We've taken the x-axis and called that depression status instead of just depression. We've relabeled the y-axis as proportion, and we've given it a title. Fraction. Why did I do fraction? Proportion of young adult smokers with and without nicotine dependence by depression status. Okay, I'm fine with that. And this last one is a comment that the legend title can be modified if desired. So over here I've got nicotine dependence. That's my variable name. But I'm going to uncomment this line. And this is a bit sophisticated, but there's different scales. There's scales along the x-axis and the y-axis, and there's a color scale. And in particular, this scale is for the fill encoding or aesthetic. So the scale for fill, there's either continuous or discrete. A continuous color would be like a color bar representing, shades of gray or say red to blue for a numeric variable. But with a discrete variable, we have distinct colors. And an option for this scale is to give it a name. And the name we're going to give it is tobacco addiction status. I don't like that. This is nicotine dependence. I keep changing the name of this variable. How about nicotine dependence status? Okay. I've put a /n in here for a new line. So let's take a look at what we get. Nicotine dependence status. Okay, there we go. That's a pretty good plot. The only thing I don't like about it right now is that nicotine dependence, the positive value of the variable, is coming down from the top, and it'd be much easier if we could read it from the bottom up to read the number off of the scale. So that gets us back to the code where I've got a comment about reversing color order. And what the heck, I'm going to copy this comment over to our code since we're using it here. And I'll put a double underscore to make that text bold. And I'll make this put it into a code by using the left tick. That looks pretty good. And the only difference in the code is this additional option that fill is going to equal the factors are reversed for this variable. Everything else is the same. So we'll come back over here. We've got the fill equaling, and this might be easier temporarily if I make that text, the space a little bit wider. Here we are. Fill equals, and I'll get wrapped immediately. Okay, so I've added in the for cats package, double colon, there's a function called function or factors underscore reverse, and it reverses the levels. So let's make our plot area large again, and when I run this, we should get these two flipping. Okay, so now nicotine dependence is on the bottom. The colors stayed with the original categories, with the same categories. We just put the blues on the bottom. Okay, so now we've got 9% and 22% for those two groups. I like it. The last option here, let's knit this and see what we get as a result. And then I may have talked about this before, but I think we'll add an option in this code chunk to change the size of this plot so it appears in the HTML at a good size. So we are at line 1135. Let me go up to the very top where I'm going to steal a piece of code from the first code chunk around line 90, which are these figure height and figure width options. So I'm going to copy that code and go back to the line number that I've already forgotten. Okay, 1136, and I'm going to paste this in here. This height of 4 inches and width of 6 inches is the default height and width of a figure when we plot something. So if I put this in here like this, it's not going to change anything because these are the values that we set originally. Let's go look at that plot. All right, so we're going to open up the output in the browser. Yeah, let's not use Microsoft Edge, please. All right, well, scroll down to graphing bivariate categorical response and take a look at, so we've got the tables here that we made, and this is the table that we're currently plotting. And here is our plot. So this actually looks like it's well proportioned already. 4 inches high, 6 inches wide. Looks good. Let's look at an example where we change this. And we'll go over here. So let's say, I think we can get away with it being a little narrower. So if we make the width 5, and it could be shorter too, let's say 3, and reknit the whole thing, right? These options are only interpreted when you knit the document, because when you run the code here and it appears in the plot window, the plot appears in whatever size the plot window is. So that's not going to affect your output. So we'll let this finish in a moment. There it is. So I go over to Chrome, I'll press F5 to refresh, and I'll make it a bit bigger. Okay, there's the plot. So what did I do? I made it, there we go, 3 inches high, 5 inches wide. And when we look at the plot, 3 inches high, 5 inches wide. The text now looks a little bit larger because the text size has basically a fixed size, a fixed point size in the plot. So when you scale the size of the plot, you are affecting the relative size of the text in the plot. That's one thing to watch out for. But it looks like all the text is fitting. You know, the title isn't being cut off outside of the window. If you were to make this much narrower, you'd see that the text of the title would be cut off because the width of the overall figure could not accommodate the width of the text for the title. But this looks pretty good. I don't think I like these spaces I put in here in the front, but otherwise I'm pretty happy with this plot. I can fix that space right here. Okay, so you can see that after in the title, after the line return, the bracket or the backslash n, I have a space, and that's what's adding this little tiny space in the plot right there in that title. I'm just going to remove that, and if we just rerun the code right here, you'll see in this window on the bottom right that the nicotine is going to move left and be justified with proportion. Okay, that looks a bit nicer. That's our first plot, and there's more I could say, but I think the only additional details I'll say at this moment is for this other multi-category example where we're looking at, maybe I'll talk about this. You can see in this plot I've rotated the labels. In this case, there's really no need to do that because they didn't run into each other. If I page up in the previous example, these labels aren't overlapping, so we don't really need to make space. But this is how you do that. In the theme, there's lots and lots and lots of options. One of them is the axis, text. Which axis? The x-axis. We're going to change the text by changing its angle, by rotating it 90 degrees. And rotation in R is just like in mathematics, it's going to be counterclockwise. So a 90-degree rotation rotated the text 90 degrees counterclockwise. And the other adjustment here is a vertical adjustment. V is vertical, just is for justification. And 0.5, I forget what 0.5 does, but it appears that probably these are centered. The thing is that no depression and yes depression are both the same width, so it looks about the same. It looks like there's slightly different distances from the axis, so I think this might be centered. The three numbers that you're most likely to see are 0, a half, and 1, where I think 0 might be left justified and 1 might be right justified, with 0.5 being centered. Okay, let's do one more example. Here's an example where they were not rotated 90 degrees but 45 degrees. And you can see also that they're all justified to be the same distance from the axis. So now we're going to get the answer to that question. Here I did use the theme. The angle is now 45 for the text. The vertical adjustment is 1, so that's going to be sort of right justified but vertically. So right justified vertically, we'll put them all on this axis. And it looks like I've also used a horizontal justification of 1, which is, I think, it's going to be right justified. Anyway, so they all appear to have basically the right side of the text to be lined up with the axis. If you change the horizontal adjustment and justification to 0, then the left edge of these words are going to line up with the tick mark. Okay, so that this will be shifted to the right where the E lines up with the tick mark. I think it's easier to read if the right end of the text is lined up with the tick mark. Okay, so that is really all I want to say about these two-way categorical plots. I think this is probably a good place to stop this video, and I'll come back to talk about the logistic regression plots.